In the third problem in calculating buffers, we need to find the grams of potassium phenol that when we add it to 450 milliliters of 0.485 molar phenol, we get a pH of 4.850. Right? So, we have no way of directly calculating grams of anything using our expressions. What we do have is the HH equation that tells us pH equals pKa plus the log of the A minus over the concentration of HA. So, I have pKa because they gave me Ka. I have concentration of HA because it was given to me also. If I could find the concentration of the A minus, the only other source for A minus is going to be potassium phenol. The A minus is this, OC6H5. Right? So if I find this, I then have a way to find the grams of that. So to begin with, we can just substitute things in. That 4.850 would have to equal the pKa, which was going to be the negative log of the Ka, which is 1.6 times 10 to the minus 10, and that's going to be added to the log of the concentration of the phenol, which is OC6H5, but I'm going to just keep calling it the A minus right now because it's a lot shorter to write, over the concentration of the phenol, which was given to me as 0.485 molar. So at this point, the only thing I don't have a number for is the A minus, so I can solve for it. Now, first thing that I do, 4.850 equals, what is the negative log of this number? That turns out to be 9.795. Now, right away, I can tell that when I wrote this, I either moved a decimal or I did something funny, because if I'm making a buffer, I want to stay plus or minus 1 away from the pKa. And if I'm trying to make a buffer that's all the way down here, it's going to be very challenging. So I might come up with irrational results. So good luck trying to really do this. But we can still do it on paper because the system for doing it is consistent and reliable. So, we have a little bit of flexibility, but if I first take this over to this side, subtract 9.795 from both sides, I turn out that negative 4.945 will equal the log of A minus over 0.485. If I now take the anti-log of both sides, 10 to the negative 4.945 will equal concentration of A minus over 0.485. Which is to say that the concentration of A minus is going to equal 10 raised to the negative 4.945 times 0.485. And I find out that the concentration of A minus, in this case, equals 5.50 times 10 to the minus 6 moles per liter. Okay, great. Now I know this number. This concentration, which is going to be the same concentration of this potassium phenol that I have to put into the beaker. Now that beaker is only holding 450 milliliters, so I have to use one of the relationships that is not provided by the AP exam. That relationship is the fact that since molarity equals moles per liter, that if I know the molarity, the moles per liter, I can multiply that times liters and I will end up with moles. But also the relationship that molar mass equals grams per mole. That's the unit. So if I want to find grams, I can simply do molarity times the volume in liter times the molar mass, and that will give me the grams because each unit cancels. So that means it's 5.50 times 10 to the minus 6 moles per liter times 0.450 liters times the molar mass of this.